Alrighty everyone, so we're coming in on the conclusion of this canvas piece. All we really need to do now is make sure that we're continuously spawning stars during the duration of this canvas piece. So when we refresh the page, we only have that one star that spawns from the very top, but now it's time to create the multiple stars. So we get one there, we get one there, we get them all coming down. It's going to be freaking amazing. So let's go ahead and implement the multiple star spawning. So we know that a star should be spawned randomly as time increases. So if we go on down to our implementation section, we are going to add a let called ticker. This is just going to act as a timer. All we're going to do this let is add 1 to it over and over and over again within our animate function. So if we do exactly that and say ticker plus plus, all this says is we are adding 1 onto the current value of ticker. And we go ahead and console log this out. Let's go ahead and console log out the value of ticker real quick. You're going to notice in our console over here, that we get not a number. So, okay, this is an error on my part. When we declare ticker up here, we want to make sure that we set this equal to 0. And you can either do this within the init function or up here. It's not going to make too big of a difference. But if we set this to 0, look at our console log, you're going to see that we're adding 1 into ticker over and over and over again. Okay, that's great. But now we need to actually determine, based on this ticker, when do we actually spawn the stars? And we're going to spawn the stars whenever this ticker is divisible by a certain number. And that number is going to be randomized. But first, let's just go ahead and spawn the stars when this ticker is divisible by, let's say, 75. So we can say, if ticker is divisible by 75, like so, then we want to push, we're going to use our main stars array. So that's this one right here. We want to select our stars array and we want to push a new star into this array. And this is going to have randomized coordinates. So to get a random x value, we can make a const right here. Say that it's going to be equal to x, and we want this x coordinate to be anywhere from the left and right hand side of our canvas, just like we did within the last episode. So we can say, let's see, math.random times canvas width, and then we can add that into our star function right here, and then we're going to do the same thing for y. Change this to y right here, change width to height. Actually, what am I doing? I'm not even thinking straight. Okay, we're not doing this for y. We want to make sure that all of our big stars spawn at the very top of our canvas. So we're just going to say have all of our big stars spawn, let's just say 100 pixels above the top of the canvas. Okay, sorry about that. I got a little sidetracked in my mind. I'm getting a little crazy over here, but okay, so we have an x coordinate that's random. We have our y coordinate. It's always going to be at -100. And now we need a radius. Let's just go ahead and set our radius equal to 30 for all stars. And then finally, we need a color. And what is the color of the main star we're using? I guess it's just white. So we can just go ahead and say our color is going to be white. And with that in effect, let's go ahead and get rid of that one star that we created in the beginning. You can keep it if you like. It's not going to be a big deal if we get rid of it or not. But now every time, every 75 frames, we should see a new star spawned randomly from the top of the screen, anywhere from the left to right hand side of our canvas. So let's go ahead and save that. And wait a little bit, and there you go. You'll see that these are being spawned in random locations, and we have a nice little effect. We have all the stars spawning randomly. It's just fucking cool, I guess, honestly. But we can make this a little bit cooler. So this isn't really randomized. It's they're spawning every 75 seconds, but it would be a lot cooler, a lot more, I guess, just a lot more intriguing if this value was changed each time a star was actually spawned. Okay. So in order to do that, here is what we are going to do. We are going to create a new let right beneath our ticker. This is going to be equal to random spawn rate. And we can just set this equal to 75. So the first time a ball spawns is going to be after 75 frames. And we're going to replace 75 down here with random spawn rate. Okay, so whenever we spawn a star, we want to set this to a new random value. So what we can say is Once we spawn a new star, our new random spawn rate is going to be equal to math.random. Actually, we can use our utils function, so we'll just say utils.random int from range. And let's make this equal to anywhere from 75 to 100. And this is going to give us a little bit more variation between each time an actual star spawns on the screen. And so let's watch it now. And we definitely have a little bit more of a variation. Let's go ahead and amp this up a bit. Let's go ahead and turn this up to 200, and we should be able to see it even more. Let's go ahead and watch it. Okay, so now we definitely have more variation, and we're getting closer and closer to the actual canvas piece. These stars are pretty darn big, I would say, so we probably want to decrease the size of them by a little bit. So let's go ahead and tune this down to, instead of 30, let's just say 18. Let's see how that looks. I don't actually know. 18. Maybe even a little smaller. Let's just say 12 and see how things look. Remember, this number should probably be divisible by 3 because we're removing stars when the radius is 0. If you get anything less than 0, then you're going to get that JavaScript error. So just make sure that this is a radius of, or that this number right here is divisible by 3. Okay, so I think I'm going to keep 12. This is all fine and dandy, but now we need to make sure that our big stars are kind of have some left and right movement in the actual piece. So we need to go back up to our star blueprint, keep on going up, and within our update function, we are not just going to add a y velocity, we are also going to be adding an x velocity onto each individual star's x coordinate. So we can say that this x is going to be equal its current x position plus the x velocity that we set within the star. So right now our velocity is 0, meaning that even if we add this right down here, we're not going to see any left and right movement because there is no left and right movement. We need to specify that this x velocity should be a random value, and it probably shouldn't be too much, but let's go ahead and say this should be a random int from range. Random int from range, anywhere from, let's start off with -4 to 4 and see how that looks. And okay, yeah, no, that's pretty cool. I would say that this is a good number to kind of sit on. If you don't want to use an actual integer and you kind of want things to be more precise, what you can do is you can use a math.random function like this. This is going to return any number from 0 to 1, and if you subtract 0.5 from it, it's going to give you any number from to -0.5 to 0.5. And since we have either a negative or a positive number, what we can do is we can just multiply this by something like 8. So this is going to just give us a negative number, a negative or a positive number, but things are going to be more precise since these are not going to be integers. Okay, so this is looking pretty darn good. I would say we're almost there right now. But in the actual canvas piece, we also have these bouncing off the left and right hand side of the screen. So in order to add that kind of collision detection for the left and right hand side of the screen, we're just going to add an additional conditional. That's a fucking tongue twister, right in our update function. So when a ball hits the bottom of the screen, we're calling this conditional in these functions. But when a ball hits side of screen, we're going to call this conditional. So when a ball's x position plus its radius plus its x velocity is greater than the canvas's width, we want to reverse that x velocity to go in the opposite direction. So we're going to say this dot velocity dot x is equal to a negative this dot velocity dot x. So that should take care of things for the right hand side of the screen, but we also need to take into account the left hand side of the screen for all the balls over there. So we'll want to add an or statement into this that says if this dot x minus the star's radius is less than equal to 0, then we also want to reverse the velocity. So this should be okay, I think, but we might run into a few bugs. Let's make sure it's bouncing. Okay, they are bouncing off the left and right hand side of the screen, and we can also add some friction onto this just as a side note if you want them to slow down based off the hits on the left and right hand side. So we can reference our star's friction and just say this dot friction, and things will slow down based off when they hit the side over there. But we might run into some issues where a star is spawned right on the edge of the screen, and I don't know if we'll run into it while we're watching this, but if we don't determine that our star should only be spawned in a specific area and that they should not be spawned directly on the left and right hand side of the screen, we're going to get issues with our collision detection, and as a result our stars are going to get stuck on that side of the screen, and they're just going to be spawning multiple stars if we decide to call the shatter function as a ball hits the side of the screen. So I know, there we go. Okay, so some of the stars are stuck on the left hand side. They can't actually bounce. It's kind of hard to see. You might need to rewind it, slow things down a bit, but let's go ahead and prevent this from happening. So where are our stars being spawned? They're being spawned within our animate loop, and they're being spawned anywhere from the left to right hand side of the screen. But that's not going to be good enough for us. We want to make sure that they are either spawned 30 or whatever our radius is, so 12 pixels from the left of the screen, anywhere to 12 pixels from the right of the screen. And as a result, we're making sure that they don't get spawned and caught on the left or right hand sides of the actual canvas. And basically, to ensure that these are being spawned within the canvas and not getting caught on the edges, we want to subtract our radius, so 12. And we can even create a radius constant up here, just so we're referencing, just so we know what 12 actually represents. It's going to be good for legibility purposes. We can say we want to subtract our radius from our actual canvas's width. That's going to make sure that we never spawn things on the right-hand side of the screen, but we might still have the issue where we're spawning stars on the left-hand side of the screen. So what we can do is, we can say, whatever this produces, we want to get the maximum value between what we have right here and 12. So we're always going to be spawning anywhere from 12 to whatever random value that we have right here. This math max, this is just kind of like a fallback in case we get any value from 0 to 15. So this should spawn things within our canvas every time. And really, I think all we have to do now is kind of just play around with things, kind of toy around with just the variables to make sure that they are as accurately represented as possible. You don't have to get it as accurate. Really just play around with the gravity, friction, and so forth until you get something that you're actually happy with. All right, so last thing is we need to create this floor that we see right here. So let's go ahead and do that now. And looking at this, what do you think a floor consists of? Really, it's just a rectangle that extends from the left and right hand side of the screen, and it's about 30 pixels, 40 pixels tall. So let's go ahead and add that in right now. Okay. So to add in a floor, we can just go directly to our animation loop right here, and beneath the create mountain ranges, we are going to say c.fill style. We're going to be changing the fill style of our floor just so we can differentiate it from the rest of the stuff going on in the background. And this fill style is going to be equal to 182028. And this is going to give us a nice dark ground. So now that we have this fill style, we need to actually draw the floor onto our canvas. And we can say c.fillRect to create our rectangle, and then we want to say that this is going to be starting at an x-coordinate of 0, and then our y-coordinate is going to be canvas.height minus whatever our ground height is going to be. So let's go ahead and create a variable for ground height, and then we'll create that variable up top in a second. And then the width of this rectangle. The width of this rectangle should be the width of the canvas since it goes all the way from left and right hand side of the screen. And then the height of this is going to be ground height. So the reason we're subtracting ground height from the actual canvas height is so that we have, that's just where our y-coordinate is going to be. And remember, since our coordinate system is reversed, we kind of have to do this minus thing from the canvas height. So now that we declared all of this, we're going to get a JavaScript error because we never actually declared a ground height, but we can do it right here beneath our random spawn rate. Let's just say our ground height is going to be equal to, I don't know, 100. That should be okay. And let's see what happens. Okay, so we're still getting ground height is not defined, and I think it's because, yep. All right, so this should be a capital H. Just make sure that you declare this variable correctly and that you're referencing it exactly as is. And once we do that, we now have a ground within our canvas piece. But our stars aren't actually bouncing off the ground. They're bouncing off the very bottom of the canvas. That's because our collision detection code isn't set for our actual stars to bounce off that little ground piece that we just created. So if we go on up to, we're going to want to stay within our stars update function. We're going to want to say when the star's y coordinate plus the radius and velocity is greater than canvas height minus ground height, that's when we want these to bounce up. So let's watch what happens. And now they are bouncing off the ground just like we would expect them to, but our small particles are still going pretty crazy at the very bottom of the canvas. We need to make sure that we're subtracting ground height from our canvas height, also within our mini stars update function where we're determining all this collision to happen. So we go ahead and do that. The mini stars are now bouncing off the floor that we just created. One more thing that we might want to add onto this now that we've created the floor is we might want to add a shatter effect when these hit the side of the screen. So let's go ahead and add shatter not only to our Y collision right here, we're going to go ahead and add shatter also to our X collision. So whenever it bounces off the side of the screen. And that should just give a little more interest to the piece, just creating more explosions as these balls kind of go from left to right. And I kind of want this to happen a little more. There we go. You can see it right as it hits the side. But yeah, I would say this kind of finishes things up. I mean, we just created Star Shower basically as is, probably with just a little bit different variables, a little bit of different properties. Things aren't going to be exact, but really you can play around with all these properties, things like friction, things like gravity on the mini stars, on the big stars too. How many times you want these to spawn, and you can get pretty much anything you can think of. Just have fun with it. Go ahead and leave your finished piece in the comments of this video, and yeah, feel free to go ahead and leave a like, subscribe if I helped you out in any way. I'm trying to exit out of the console, and yeah, I really appreciate you guys for tuning in. Hope you guys learned a lot. Hit that like button, subscribe, and I'll see you in the next episode. It's probably going to be a whole course on Webpack, so see you then, guys, and have a great night, day, wherever you are. Peace.
Ha ha ha! Ha ha ha!